Okay, so this is my talk, Rapidly Building with Gleam. I'm Peter Saxton. You can find me on the internet as Crowdhailer all over the place. I work for Indie. We do direct channel marketing and research via messaging apps, WhatsApp at the moment mainly. I'm also organizing the first dedicated Gleam conference, Gleam Gathering. So if that's interesting, check this out. I've also written my own language, which we might talk a little bit about as well. And the rest of the time when I'm not working on the other startup, I'm trying to build a startup on this one. So there's a lot going on. But yeah, now the talk. So the original talk. I was going to talk about just how to get stuff done quickly. Like Gleam gives you some abilities which are unique, and then there's a lot of stuff which is just good software engineering, which is worth paying attention to. However, I looked at the program that some of you may have sat through today, and really, it looked like a lot of this was going to be covered. I mean, even the use of boring, and my example for things to get rid of was the ORM, so kind of cheers, guys, you all got there first. And the new kind of sketch for what we have to talk about is we'll cover these things. We'll go into a few more of slightly like my opinions and maybe where stuff can go in the future. So we'll start with sensible advice followed by my opinions. So focus on need. So I don't know, hands up who knows this quote or have seen this before. So this says, building the right thing is more important than building the thing right. Cool. Well, one hand. So essentially, I've paraphrased this. This is not the original quote at all. What I was trying to remember is from this guy, and he said this a lot. So management is doing things right. Leadership is doing the right things. He also said efficiency is doing things right. Effectiveness is doing the right things. And my favorite version is there is nothing so useless as doing efficiently that which should be not done at all. And these all come from Peter Drucker, and he did a lot of stuff about management. And this advice all holds. This reminds me to slow down at key moments. But yeah, so building the right thing. Like, this is really important. So, when building the right thing, you should always bear in mind, like, the actual problem statement. And the problem statement is not just, like, what you want to solve, like, this Rust compiler's too slow kind of thing. It's, who is experiencing the problem and when are they experiencing the problem? And if you build a solution, try and build a solution for where your users will be rather than where you wish they were, and, all of these good things to bear in mind. But I do like to kind of caveat building the right thing with, so I've written my own language. That's not necessarily a good use of resources if you're being maximally productive. But if you put the right questions, you say, okay, I'm always curious how languages work. Who has the problem? Myself. And when I'm discussing, so at the time I was helping with Gleam development, there was a thing I wanted to resolve, and I built myself a language to teach myself about languages. And at the time, to kind of double down on these things, the language was called language. It was in another repo which was called notes. So to find it, you would have to go to my notes repo, and you would have to go to a folder called language. It was utterly ungoogleable, and I couldn't get GitHub stars. And that was a feature because I never wanted to get to like 15 eyeballs on it and sort of like make it better for them, because that was never the goal. The goal was always like solve my problems. So yeah, you can build really crazy things. I encourage people to build really crazy things. But if you're building a crazy thing, build the crazy thing. Don't try and popularize it. If you're trying to make something popular, work out who you're popularizing it with. This is another way of putting it. So yeah, if you want to start writing, get a blog which is ready-made. If you want to learn a new technology, make sure you're already writing. Doing both at the same time is really just setting yourself up for failure. And this is good advice. So this is your sort of first nugget. And making sure you're building the right thing. Names are really important. So if you can't explain something, do you understand it? If you can't name it, how would you possibly explain it? Great advice here. And one of the things I do here with naming, long names are my favorite. So if you don't know what to call something, if you have something called user, but they're like a signed-in user, but maybe only sometimes a signed-in user, the best variable name is user before they're signed in when I have a session, but not an account. Just write it all down. Don't pretend that your system is more organized than it is. And finally, on this section, I believe, what you measure matters. So setting up code coverage tools is a classic building stuff right. You feel better at the end of it. But if you're building the wrong thing, it's not helpful. Anything around pull request statistics or just productivity advice in general, if you're going in the wrong direction, you need to avoid it. And you have to take time. You have to take time to work out the right direction. This is not a Peter Drucker quote. I believe like the Navy SEALs or whoever like this, but I couldn't work out where it came from originally. So yeah, if you don't know what you're doing, just calm down. You'll go faster if you crack on. If you don't crack on, if you just check out, talk to someone in the know, this is good advice. So seek fast feedback. So a lot of that was about slowing down, but once you've done something, don't let it sit around. And there's a lot of this is where we're getting into a bit of a nuts and bolts. Code reload, test quickly, deploy quickly. Suffer, I put here, suffer real user feedback. Because you should. Like if the feedback from a user is like, yeah, great, 100%, you released it too late. This is a library I've written for reloading. This works for Mist and Wisp. So the Gleam ecosystem is slightly new. You don't have a kind of ready-built framework for the backend with all the things. There's no generator. You won't get a Rails new with a reloading and a database in place. But all the pieces are there, and you can put them together. This is my one slide for test versus types. We are in the Gleam track, so I won't dive too deep. But when you're talking about feedback, I think types have one key edge over tests is to get the benefit from a test, you have to write the test and write the code. To get the benefit from the types, you only have to write the code. And if you get the benefits from the language server, which you do in Gleam, rather than the compilation step, your feedback loop is increased. So it's not that types are good, because if the Gleam compiler was a back office thing where you sent off your post and they said getting back to you in 48 hours, it wouldn't help, right? So a lot of these conversations, feedback is what you're actually going for. And types versus tests, maybe I'll just take whichever one's fastest. I don't mind. And so back to the Peter Drucker quotes, which I quite like. Plans are only good intentions unless they immediately degenerate into hard work. So with the test versus type thing, if you don't know how many tests you should write, just start. If you write too many, it'll take too long. If you write too few, you'll have too many bugs. If you discuss it beforehand, you'll still end up on one of those two tracks. You'll just maybe on the other one. You will always have to do feedback. And then, this is a guy. You don't necessarily need to read this. This is from a podcast he was talking about with Lex Friedman. So Peter Levels is a guy who champions. He's a digital nomad. He's famous for building a lot of projects. And he had this sort of comment when he was asked how often does he push to production. And the number is here. He made 37,000 commits in a year. Okay, and he does this by having a keyboard shortcut, which when he presses Command Enter or whatever it is, it creates a commit with no commit message and pushes it straight to main. Maybe you don't want to do this. Quite probably you don't want to do this. But whatever you process you add above that, you need to remember that you've increased your feedback loop by whatever amount that takes you more than 1 second from code to production. So sure, set up CI, set up all of these things. But yeah, keep in mind what you're losing. If you are trying to build rapidly, you have to ship rapidly. Be boring. Okay. Just use Postgres. Yeah, do so. Cool. So other good places of advice, I don't know. I mean, if we talk to Elixir people, a good number of them have messed around or professionally developed Rails, it could be both, for many years. If you have a resource like a user, this is actually from the Indie where we have a flow, which is a conversation. If you want to create, update, and delete those, and they're going in your Postgres database, name everything the standard way. There are 7 CRUD actions. This will be a more boring part of your application. Use those names, use those paths, crack on. And this is kind of showing you, this is all very possible in Gleam. There's no framework here. You don't need to adopt a framework to get the conventions. You can use the conventions without the framework. So, okay, Docker. I tried Podman. I've tried Nix. I use Docker. I don't like it. I do. It's boring. It's got the best documentation. So in dev, I run everything in Docker because that's what I'm using in production. And in production, I use Docker Compose. Maybe I should be clear. This is in my personal projects. I use Docker Compose. We do have a guy who does a bit more of the AWS stuff at Indie. So this is not entirely true. But I have raised money off projects which we're running Docker Compose on a VPS. This is my Docker file. I don't build releases. I use the same Docker file in production and on dev. The production Docker file has Git installed. It also has iNotify tools installed. My VPS is fine. It's really big. It's not the thing that's blocking my progress. I could have 2 Docker files. It would mean that my local development was further removed from production development, and it would be longer to get feedback from exactly the same environment. So this is my permission. You can just use this one, and you can run Gleam run in production. When you come up to a limitation, then you can level up. But you can there is always a simple, dumb approach to stuff. You're welcome to use it. Manage secrets one way, and don't manage configuration at all. So if you're building one application, so for example, here we have one that's got an Olama backend. In the development environment, everyone's development environment uses the same password, not so secret. It's not worth your time forgetting to set an environment flag. Just put it in the repo. I quite like this advice because I've worked with people who spend a lot of time making their application very configurable, but then they also add into the repo a lot of infrastructure as code, which in my mind is taking the configuration and defining it back in your repo. So that's a lot of homework to describe a lot of environment variables and then define a lot of infrastructure as code to put values in those environment variables when they could just be magic numbers at the top of your code. Again, if you have multiple deployments, then you need to configure between those deployments. If you don't, then you don't need them configured. That's my 2 cents on that one. Cool. So yeah, eliminating unnecessary components. Components can be anything. So, if you can remove boundaries between your application, use the same types on the client and the server, that's great. If you can eliminate tools, even eliminate concepts from what you're building, so much the better. So this is the, there's a lot of quotes. Essentially, I think what this talk is to give you really trite ways of convincing your colleagues that you know what you're talking about. Like if they're asking, no, I didn't have time to write you a short letter, so I wrote you a long one. This is saying that simplicity actually takes work. So all these things about throwing components away, it's really easy to just think you're binning stuff and then, okay, why wouldn't we use them? What's the harm in X, Y, or Z at all? You're moving away from simplicity, and simplicity is worth pursuing, but it does take some effort to pursue it. So that's fair enough. One thing which I've come across a few times, which I highlight this because I made this mistake quite recently. Build a single application. So what do I mean by this? We're quite often building SaaS applications. We're building applications that live on the web. So Lustre, I don't know if you've been in here if it talks about Lustre. Lustre is a great tool. I've used Lustre for a couple of applications. Lustre is great for browser apps. So you make a rich browser application, something you might be able to install. So I have used it to write a rich text editor. It's great for this tool. I then moved on to writing an application that was not a sort of browser app. It was a web app. And we need better language for this, if anyone can come up with better suggestions. It was a sort of back-end first application. All of its functionality was interesting because of the database it was able to talk to, and actually, in this case, the LLMs that it was reaching across the cloud. I built a back-end, but I also built a front-end with Lustre. The best improvement we made to this application was to throw away the front-end and go back to HTML rendered on the server. And the reason I think this was such an improvement was because we went down to making one application. Beforehand, we were making a front end and a back end, and we had to decide the JSON in between. We got to use shared decoders. We got a huge amount of help for the best way to build a back end and a front end application, but none of it compared to building just a back end application. So build a single application. This is the one I particularly highlight. And use less tech. This is, what do we got here? So this is a slide from Elixir in Action. I feel like this was originally referenced in some Erlang resource because everything says Erlang and not Elixir. Maybe I did that. But yeah, so we are privileged to use the beam. We've talked right in the keynote at the beginning how it was doing things before they were cool. So we've got the ability to use processes. We can have a cluster. We can use data native terms across the cluster, which I think is a great example of building one application. In Erlang, when you just do term to binary and send it across the wire, your whole cluster becomes one application. Great. So yeah, use less tech, by which I mean use Gleam, obviously. And yeah, use less concepts. So the use less tech, I couldn't really come up with a particularly Gleam-specific approach to that argument. But use less concepts, yeah, so the gang of 4 patterns, all these object-oriented patterns, they go away if you lean into functional programming. The talk before, which was actually really good, I don't know, I haven't seen them, but was about domain-driven design. And there's a book about domain-driven design which sort of enumerates all the OOP patterns. And there has to be a follow-up book telling you to sort of do less. Like, I have read the second book, and it just kind of lists a bunch of stuff going, yeah, didn't really need the visitor pattern. And again, you get more bang for your buck. So less concepts. So less, less, less. Great. Do less stuff. But, okay, there is a problem with this argument. Okay, so when you're building and you're reducing and you're throwing stuff away and you're going, no, 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 I don't need a transpile, I'm going to write my CSS by hand. And you're like, no, 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 I'm going to write my HTML by hand. And eventually you go back to writing your own assembly. At some point, you've made a mistake and you've gone too far. And so what is that point? So the Turing tar pit, this is the idea that essentially meriting technology based on what they can do is not actually very useful, because any Turing complete language can do anything any other one can. You can always write a Gleam interpreter in Bash. So the question of does X do Y is actually, it's a very silly question. Or at least it's a question with a very uninformative answer. So how do we square these two sides off? Like, it's great advice to build less, but if you take any of this to its logical extremes, you end up in another mess. So how do you escape the Turing tar pit? Well, they give you a little clue here, let's have support for common tasks. So obviously one of the best ways to get rid of this is to just use the NPM ecosystem. Then you've got a tool for everything, just more packages. No, that won't necessarily help you either. I think we've seen the memes about there's nothing more weighty than your package. Well, it's not your package. What is it? And no packages directory. The package JSON defines them all. So how do you escape the Turing tar pit, like with your sanity? How do you choose what things you keep? And the best term I have for these is the idea of high leverage abstractions. And I actually think these are moderately hard to identify because we stop talking about them after a while. I think that's kind of, when was the last time we really discussed, we discussed type systems. Should we have types, should we not? I don't think I've heard a single person going, well, should we have a garbage collection? Or should we revisit the concept of file systems? That's well baked in at this point. And why are they so immovable? Why do we hold on to them? Why do we not talk about them? And it's because they fade into the background. But they are completely abstractions. They are absolutely technology. And they are high leverage, i.e. you get a lot of bang for your buck. You can reuse the same thing in lots of places. So yeah, garbage collection and file systems, maybe we don't talk about them here because it's not a Beam thing, but they're in our lives all the time, so we accept them. Within the Beam, we have, I think, supervision trees are probably the thing we just yes, you start all your processes under a supervision tree. Yeah, it's a very common abstraction. It's a very powerful abstraction, and I genuinely think its success is to some degree reflected by the amount we stop talking about it. I'm going to discuss a bit about Gleam's use. For people who have written Gleam, you'll see this, but for people who haven't, I'll try and explain it a bit. And then programming languages themselves an abstraction, which of course we talk about all the time. And maybe that's because we haven't found the best ones yet. I don't know. So yeah, so supervision trees. Supervision trees are a way to do failure isolation. So the problem statement is we've got errors. We don't want the errors to affect the whole system. And they replace the concept of try-catch, but they also replace the idea of using Kubernetes. And so I think they're more elegant than either of these two solutions. But I think the reason I think they're elegant is because I'm just satisfied by the fact that one abstraction has been applicable to more places than they've managed to pull off. So I think that the elegance we see is kind of high leverage, although that's a lot less romantic way to say it. So yeah, so supervision trees, again, great abstraction. Gleams use. So, okay, so hands up people who have written, well, enough that they would happily explain use to another person. Who would happily explain Gleam's use statement to someone else? That's not many hands, so yeah. Interesting. Okay, so I'll try and explain it now. So we have this function here called try. It takes a result. A result is the union of an OK or an error. And then it takes a function. And what we're going to do is if the result is OK, so we're containing a value that we want, we map over the function. And if it's not, we're going to just pass the error through. So this is railway-oriented programming. It's shown up in a variety of places. So before Gleam use, you would have to manually feed this to get more meaning. You always have to manually build it. But you would end up with extra nesting. So the key thing here is that our OK response.body is one step in from our original call to send the request. I don't know. I mean, it's a very aesthetic thing, but this results in the pyramid of doom. If you have to put lots of these together, you keep nesting in. And so Gleam use, I'm just going to scroll around with my mouse to do this. So this function here, where you just pass in a continuation, where you take a response, you do something with it. With Gleam use, you just sort of back pass the argument out. So everything after use becomes the argument to the old function, and then all the code below is the body that was previously nested inside. So Gleam use is a replacement for, like, I think Rust has a try operator, which hits in this space. But Gleam use is an evolution of a previous concept. So Gleam previously had a try keyword, which worked only for results. But Gleam use now works for anything to which you can pass a continuation. So you can use it for promises. You can use it in your own DSLs. You can use it all over the place. And this is from the Gleam release announcement when use was added to the language. So Gleam's main goal is to be easy to learn and easy to work with. Sounds great. But yeah, so the language is designed to be small and consistent. So this is totally working with my, search for the most high impact abstractions. Like, what's the least amount of things you can put in the language, and how do you have to, if they're consistent, you have to think as little as possible about, like, remembering them. But how do you do all of that and make a language that's easy to work with? So, and then the second quote comes from just after an example of using the old code with nesting. And they don't say elegant, but they get pretty damn close with, it's not aesthetically pleasing. So I think this is another good example of code is for humans. We know what we're looking for, but we really have to search to find it. And I think Gleam use will be with us forever now. I think we've discovered a great abstraction here. Similar things sort of exist in other languages, but nothing exactly like it. It's very powerful. I think it's one of these high leverage abstractions. And it's worth it's the one thing when you really pick up Gleam that takes a little longer to get your head around, and I think it's worth it. Okay, so programming languages themselves. So, okay, now these ones we don't ignore, and I think that that's because there isn't an obvious answer. There's no such thing as like the sort of file system of programming languages. There's a variety of reasons for this. But I'm going to sort of specify a little bit more what I call a programming language on the tool for organizing thoughts. Okay, we don't write assembly, we don't write in binary. Languages are for humans, but they're for humans in a lot of different situations. So, powerful platforms. So I love using the beam. The beam is great when you have a beam-shaped problem. Okay, that's probably the number one thing you say about the beam. If I say I love Erlang and someone says I'm writing a CLI, should I use it? You go no. It's not going to give them a good experience. So the beam is this incredibly powerful platform. It contains its own abstractions, which are very powerful. We've talked about supervision trees. I think the concept of processes themselves are a very high leverage abstraction. But I would argue, and I don't know if someone might push back on this, that Erlang OTP, the name is conjoined together because Erlang is a DSL for controlling the beam platform. So the beam platform is great. Erlang is a DSL hard glued to that platform. You can do other stuff with it, but it has, primitives built in for message passing. I would reduce Erlang to the DSL for the beam platform. Browsers. Browsers are a wonderful platform. It's the universally distributed platform. If you want to get stuff in people's hands, you cannot beat just giving them a link. If you want to control that platform, you write JavaScript. Now, they don't call it JavaScript DOM. That would be too convenient for my point. But there are many blog posts which say you don't hate JavaScript, you hate the DOM. They are very much assumed conjoined. Like the document variable in your browser is globally available. You don't get any warnings if you try to call document in other environments. It's just not there and you get a crash. JavaScript was designed to be a DSL for the DOM understanding of building web pages. So Gleam is different. Gleam is much closer to a tool for thought. And the downside of this is there are no syntactic niceties for processes or promises. Okay, so it's not baked to either of those platforms. And maybe it's slightly harder to use. A new Gleam person is often going to go, how do I send a process? And doesn't necessarily like the answer you have to pull in a library. I think it's a feature, but it does take explaining. So I think Gleam, the language, is equally applicable to either platform. And it brings a bunch of niceties, like it has a way of doing imports that make a lot of sense. You have a package manager behind it. And then you have the type inference. So I don't want to double down on sort of the typed, untyped argument, but when you choose Gleam, you get it, and you get to bring it to both of these platforms. So it's a feature of organizing your thoughts. Yeah, talking about the previous talk, the functional designing with the types, you can really, really like push for it, or you can just use it to kind of catch your errors as you go along and you stick in your stringly world. And really to prove this point, so this is a project which, it's sort of mad, but if this is true, I feel like my previous point can't be wrong. This is, someone has forked the Gleam compiler so that instead of targeting the Beam or JavaScript, it targets the Nix ecosystem. So you can now write specifications for how your computer should be set up in Gleam. And the Gleam language is not in any way changed. The only thing that is changed is how it calls out the FFI, so how it calls into their underlying platform. So Gleam is as good at its job of organizing your thoughts, modularizing different things, bringing types, validating that all of your assumptions are correct in this ecosystem where it was never planned for. And I think this is quite a superpower. Like in my opinion, this is what Gleam should be known for eventually. Like I think that this is really powerful. I'm a big fan. I love this project. I never used it. I just love that it exists. Cool. So how long are we through this? So we've talked about these high leverage abstractions. I haven't really necessarily sold you on Gleam. I've just worked under the assumption that it is one of these. I think it is. Well, maybe I've sold. I don't know. I've told everyone about Gleam for ages. It's great. We love it. But once you've picked it up, it makes sense to leverage it to its maximum extent. Like once you've spent time learning it, once you've understood the use statement, once you've understood modeling with types, why not leverage that knowledge? Okay, this is your kind of sharp tool for a lot of places. So benefits for a type system. Okay, types give you a lot less errors. This is a kind of famous number from the Elm community, which I'm happy to talk about because it really is the whole, if it compiles, it won't crash. Types, really beneficial. In this program, how beneficial would a type system be? Not very, okay? So why would this program not benefit from a Gleam-style type system? And the reason is, well, it's too small. Well, one of the reasons. It's too small, and it talks to the outside world. So like types, the benefit of a type system is related to the system that you put it into. The larger the system, the more you get out of it. So what is a type system? So this is my sort of preferred argument for why they're valuable, which is a type system takes some base level of stuff that you tell it, takes your program, and checks that your program is consistent with the perimeter you define it. So in the Gleam situation, if you define FFI to the JavaScript or the Beam underneath, and you get it wrong, your program will crash. Absolutely your fault, it'll be a big crash. But the key point is if you find a crash in your program, you know to check only the FFI because the compiler has guaranteed the consistency of everything you've built on top of it. You can also put work moving the FFI into libraries, in which case lots of you can share from the benefit of a small amount of people thinking hard about defining the perimeter. So the more code you get inside, thank you, a single perimeter, the more value you get from your type system. So web development. So here we have an entirely classic web system. This one's two. Someone's decided to build the back end and the front end. I wasn't able to convince them not. So yeah, so your back end. We're using Gleam. We're having a lot of fun. It's strongly typed. It's in this nice black box. The front end, we're using Lustre. We're having a lovely time. But we're passing JSON between. Okay? This is a place where the type system can't help us. We can get a bit of help with shared decoders, but it's up to us to wire it up correctly. Our brain has to track that boundary. In the front end, we have the same boundary to the DOM, and in the back end, we have the boundary to the SQL. The talk about Squirrel helps you with the boundary to SQL, but essentially, the fact that those talk exists is a good reason for, like a good argument for the fact that once you have Gleam, your next biggest problem is talking to the next, you want the rest of the world to be into the order that you're trying to instill. So this is a nicer view of the world. So I don't know if people have played with Lustre, you have the concept of server components. So server components are client elements that are defined on the server, and there is no messaging protocol that you need to worry about. Or maybe more accurately, the messaging protocol is native Gleam things, native Gleam types that you pass in or out. And at this point, your system is less complicated. And it's less complicated, or maybe easier to reason with, or maybe not even easier to reason with. The key point is you're getting help. Okay, in this system, the types now help you over a larger boundary. You have defined the same, well, you've defined slightly less interface to the outside world because you've not defined anything to do with JSON, and you've got slightly more benefit because you've got a slightly larger application on the inside. Okay, so web development. Web development is far more than front-end, back-end. I was going to draw a diagram from this, but it just kind of started being silly, which is, you know, you've got CI, you've got make files in your local stuff. We've decided to glue all this stuff together with Bash. I don't like this. Like, why? We've had a lot of fun moving stuff to Gleam. So let's have a look along this. This is, anyone want to disagree with this statement? Anyone put their hands up? Right. Oh, okay, one. Yeah, like, it's older, well, I mean, it's not worse because it's older, but the reasons it's good are normally because it's already on the machine you're working with, which doesn't make it better, it just makes it more to hand. And so the Unix philosophy, who likes the Unix philosophy? Who thinks it's a good idea? As written here? Okay, well, I'm going to go through. So write programs that do one thing and do it well. Great. Write programs that work together. I also think great. Write programs that handle text streams. I think this is a terrible idea. I think this is an entirely untyped interface, that file systems are a global namespace of untyped values. So they're just big global variables of untyped values. That's what I think a file system is. So yeah, this is what I think the Unix philosophy is. I think you can use Rust if you want to, or Zig, or Gleam, or whatever, but you then go, please give me a totally untyped interface between them. Yeah, and why? Well, why do this? We can do better. It could be worse. Does anyone want to guess which system I'm poking fun at here? Kubernetes. First time, straight in, yeah. Yes. This is what I don't want to organize my system this way. Like, let's make up strongly typed things where we can get help systems smaller and smaller and smaller and put more and more YAML on top of it. I don't think this is the right direction. So, powerful platforms. Linux. Linux is a great platform. Like, it's a powerful platform, but your .sh files, they're the DSL for talking to the operating system. Okay. Why not Gleam? Okay. So, this is where I'm going to plug my library Midas. Midas is post 1.0, so I, to some degree, commit that I won't make breaking changes. Beyond that, it's a fairly experimental idea. I use it. You can try it, but there's lots of questions on how it should look. So let's have a look at this one. So I've built a website called Gleam Tours, where I was trying to put like Lustre examples in the browser. My build pipeline is specified in Gleam. So these T variables, these are, we talked about use and the fact that it works for more than results. These tasks, these T's, are how I compose together a bunch of things that shell out to the runtime that I'm working on. So the load tour style guides is a load of file reads from the file system. Read compiler assets, this gets some, I think some WebAssembly blob, puts it into place as well. We have two, pardon me, two applications. So t.bundle calls out to the Gleam compiler tool, and then it calls out to, I think Rollup I'm still using at the time. So it calls out to Gleam, it looks for this module, this function, and returns you a bundle JavaScript that will run just that function. So now my build pipeline is in Gleam as well. It's all type checked, like from this I'm going to get a bundle that is a string. This string can be put into a zip file. We can compose things if you have, say, a list of actions. We have this ability to do sequential, so we do them in order, and then there's a parallel version if you want to spawn a load of tasks. So your editor's helping you through this. Like the great language server is just going, you type in T sequential, and it's like, yeah, you need to pass in a list of things that also return tasks. Much easier than me trying to remember awk command line arguments. I also have this example where, so whenever I publish a version of Gleam Weekly, I share it on Bluesky. That's done in a script. That script is defined in Gleam. Maybe in total honesty, these aren't calling bash very often, mostly because of the JavaScript backend, I'm running Node.js. It's not a big deal, but in being truly honest, I'm not yet controlling like the shell interface. But technically, the Node.js interface is making syscalls into Linux. It works. It's just a larger tower underneath. Cool. So we're getting near the end. So this is from the documentation. This is another example of what's going on here. So we have this bundle call to the outside world. So the operating system is able to bundle files for me. Sorry, bundle functions. I'm able to write files. So this is how I create a JavaScript main.js file from a Gleam function. And it can be in the same project. So this main is referring to the module. So this is in the main module. And then app is just a function above. So running all of this, you will get a file written to main.js that will print hello world entirely from Gleam. Now, how many minutes we got? I reckon I've got 5, but maybe probably slightly less. 2 minutes left. OK, so 2 minutes left. This is the point where I kind of think we're sort of at, this is where we're running up against the limits of what Gleam can do for what I want to do. So my grand vision of there is no more bash, everything is in one strongly typed space. A little crack in this example. And the key thing is I have to stringly type this bundle function here. There's no way in Gleam to get a runtime reference, which would be a typed reference of this app function, and go back to that, the source code. There's techniques for this. It's like closure serialization. You can do witchcraft in JavaScript to make it true. But yeah, not quite possible. And at the end, I want to go even further. So this is what I really want, is I want to be able to type check over time. Like, why not have the type system tell me that my deployments are good? Possible, not with Gleam, not yet. So yeah, so that's the push. I don't even really know what this would look like in Gleam, but I like this principle of just like really leverage this abstraction. Like, I've learned the types, they're good. I can model my domain. Can I model the domain of my CI pipeline in it as well? Cool. So thank you. And one last plug, conference in the new year, if anyone would really like to get more Gleam. Thank you.
Thank you a lot. That was a lot of content, but it actually leaves us some time for one quick question, if anyone has a question for the presentation. Not really, so okay, I have one quick question. So we talked about matching, like using Beam to solving beam-shaped problems. Like,
yep.
Do you feel that the appearance of Gleam somehow expanded the collection of these beam shapes?
Very precisely, I don't think it expands the collection of beam-shaped problems, because the new problems you can tackle with Gleam are the ones when you choose to compile it to JavaScript, which I think is not a commentary on the beam. So I've seen people compile to JavaScript and put them on like lambdas. I would argue that's not a beam. I mean, maybe the better answer is like, what does it matter? But yes, like if you run a lambda or you run something in a browser or you make a CLI tool, they're not beam-shaped problems because, well, for a starter, Beam's really good for keeping a system up for many years. A CLI tool just ends. You don't need a supervision tree for something that runs for 5 seconds. So I don't think the Beam should try to expand what beam-shaped problems are. The beam-shaped problems are perfect. But that runtime and the space of modeling your thoughts don't need to be the same thing.
OK, thank you.